Commencing test in 3, 2, 1, engage. That's fun. This has been an absolutely ridiculous endeavor. If it's not evident from the ever-present dog hair in all of my videos, my girlfriend and I have 6 dogs. And we love them to death, but hot damn, cleaning up after them is basically a full-time job. A full-time job that Lauren ends up doing most of the time. The other day I was talking to a friend of mine and they were complaining about cleaning out their cat's robot litter box. And that just made me think, if there's robots to clean up after a cat, why do we not have robots to clean up after a dog? Instead, we're out here day after day cleaning them up manually like some kind of primitive screwhead.
All right, you primitive screwheads, listen up.
Now, admittedly, this isn't the first time I've had this thought in my life, but it is the first time that I thought, maybe I should try and build one. And this sounds like a great premise for a Doomsday Protocol project. So with that, let's put 2 weeks on the clock. For a problem like this, we shouldn't commit to any solution until we evaluate all our options. So first, let's define the problem. In this case, the problem is, the current method of cleaning up after 6 dogs is time-intensive, repetitive, and inefficient, indicating a need for a more automated and scalable solution. So that's the problem definition. Now, before we go inventing some insane contraption, we need to set some ground rules. So let's define the requirements. First, this must minimize human involvement. The whole point of this thing is to do less work. If I still have to deal with this every day, we didn't really solve anything. Second, this must be sanitary. This thing can't make things messier or be hard to clean. If that happens, we're already starting in a bad place. Cost. This needs to be reasonably priced, especially for a prototype. We're proving a concept and not building a finished product. Minimally invasive. I don't want to tear up the yard or completely redesign the space. This whole thing should be really low impact. And of course, our good old 2-week time constraint. If we don't meet that, this whole thing's bust. With our requirements defined, let's brainstorm and compare some possible solutions. To compare these, we're going to use an engineering decision matrix, also known as a Pugh Matrix. Basically, this is just a structured way to evaluate multiple ideas against the same criteria, so we can make a decision based on data instead of just winging it. So let's look at some of our concepts. First, we'll have a control group. This will be our baseline, where we just consider manual cleanup. If a solution doesn't beat this, it's actually a worse solution than just picking up the poop manually. Second is some type of autonomous collector. Now, we've all heard that horror story of a Roomba running over a dog turd in a house and turning the floor into a piece of modern art. It's real, it happens, it's happened to me, I'm sure it's happened to some of you. Modern day robots are mostly equipped to avoid that, but in this case, we need one that does the opposite. Find the mess and deal with it. Dung beetles. Dung beetles are nature's cleanup crew. They're low effort, fully autonomous, they're probably a little unpredictable, and bringing them into a different biome is probably questionable, but let's put it on the list. And for our final consideration, let's look at Astro Turf Conveyor Belt. This leans heavily into behavior that we already have. We already have Astro Turf, and our dogs already know that that's the place to go to the restroom. So instead of having to chase down the mess, instead we just move the surface itself, and everything gets carried away into a collection point. Now we need some criteria to judge these different options against. Reliability. Does this actually work consistently? Complexity. From both a build and sanity standpoint, this can't be overly complicated. If this thing requires splitting atoms just to clean the yard, then we've made things objectively worse. Dog acceptance. If the dogs avoid it or are terrified of it, it's useless. Hygiene. This is already a messy problem, and if the solution makes it worse, it's a no-go. Maintenance. In a perfect world, this thing just works. The less we have to interact with it, the better. Alright, so let's go ahead and evaluate these different options based on these criteria. The control group, manual pickup. It fails the whole less work requirement, and is only as reliable as the person doing it. Aside from that, it's a great system. The robot, flexible, but high complexity and risk, and also I think would require just as much cleaning as a regular Roomba, if not more, and those things are already a pain in the butt to take care of. I think it's also telling that a number of companies have tried to do this over the years and never gotten to market. And now for my personal favorite, the dung beetles. Complete low effort. However, I looked into it and it's very legally questionable to bring them into this area, and also they're not designed to survive in cold weather, and we get a lot of that. If you live in the desert, they're probably a perfectly viable solution, but they're not going to work here. And last but not least, the Poo-veyor Belt. Simple, predictable, and aligns well with how our dogs already behave. So let's go ahead and tally up the scores. Coming in at a very slim margin is Poo-veyor Belt. The Astro Turf Conveyor Belt comes out on top. It's simple, scalable, and checks the most boxes without introducing a bunch of new problems. So now for our criteria for success. If after 2 weeks we have a working proof of concept that can clear the area without me having to go out there and deal with it manually, that's a win. And with that, let's go into the design. So to get started, let's take stock of what we're working with. Gonna need some AstroTurf, which is great because we have some leftover sections from before we upgraded our backyard. For the rollers, I'm thinking PVC. It's cheap and easy to work with and should do the job. For the support frame, I'm thinking 80/20. 80/20 is extruded aluminum. It's super common in prototyping, lightweight, easy to work with, easy to assemble, mostly, and very modular. It can definitely be on the pricey side, but I've got a lot of scrap pieces lying around, so we're going to take advantage of that. Now for the underlying premise. A typical conveyor system like you'd see on an assembly line uses multiple rollers or a low friction bed to support the belt. That works great, but it gets complicated and expensive fast. More parts, more cost, and more importantly, it becomes something permanent and invasive, which goes against our core constraints for this project. The other issue is tension. Most conveyor belts rely on tension to perform properly, and if we tension this AstroTurf, it's either going to turn it into a trampoline type surface, or we're going to have to elevate the whole thing and put it on a platform, which the dogs are probably not going to be down for. Or even worse, we would have to embed it into the ground to make the surface flush with the rest of the yard, and that's a no-go also. That's super labor intensive and way too heavy-handed for what I'm going for here. So none of those are great options. So then what do we do? The approach I'm envisioning is channeling an old device, namely a laundry roller press. Instead of relying on tension, it uses 2 rollers in compression to squeeze the fabric through. And AstroTurf is basically just really aggressive fabric. So if we apply that same premise, we can generate enough friction to move the turf without needing to keep the AstroTurf in tension throughout the whole system. And that's great because it means the AstroTurf can then just lie flat on the ground when it's not actively being pulled in. No platform, no excavation, no major changes to the yard, and because the turf will lay flat, the dogs will probably use it. And I know this because anytime there's a stray piece of AstroTurf in the backyard, the dogs frequently decide that that's the spot. We may end up needing some kind of small ramp to help the payloads get over the hump on the roller, but we'll figure that as we go along. And I think that's about as solid a starting point as we're going to get. And so we should probably just get into CAD and start drawing this up. So to get started, we'll model up our rollers, which are going to be made out of ABS PVC pipe. We're going to use 4.5-inch rollers for this because that's the biggest that I could find at the hardware store. Having a large diameter ensures maximum surface area contact, which ensures maximum friction, which will help us transport the AstroTurf more effectively. The width of the roller is determined by the width of the AstroTurf that we'll be using, which comes out to 59.5 inches. I also model flanges for the ends of the roller, which will help retain the AstroTurf, as well as provide a mounting mechanism for drive systems. I also model up a gutter that will act as the collection point for the payloads. Next, I model up some 1-inch steel conduit that I have that I plan to use as a shaft. Now, ideally, in a roller system, you want to use dedicated shaft rods, but those can be pricey, and I know I have a lot of 1-inch conduit on hand, so I'm going to use that instead. Next, I'm going to import some pillow blocks from McMaster-Carr. A pillow block is essentially just a bearing that's in a housing that allows you to mount it onto another surface. Next up, I'm adding a bike sprocket to act as a drive mechanism. I happen to have a large bike sprocket floating around my garage that I plan on using, and I don't have the exact model for it, but I know I want a high gear ratio, so I basically just pick a large sprocket off of CAD-ed. Next, I insert another shaft and pillow blocks to act as the far side roller. This is essentially just an anchor to keep the system aligned, and to constrain the Astro Turf Belt. Speaking of belts, now it's time to design the Astro Turf Belt itself. SolidWorks has some really awesome and intuitive belt design tools, which is what I use in this instance to make the belt and then make it look like AstroTurf. By measuring and getting the average AstroTurf section length, I can multiply that by 4 and supply that as the belt length, which can then in turn be used to drive the rest of the assembly distances. After that first day of CAD, we're on to day 2, and on this day I start by drawing up the ramp that I'm not sure that we'll need, but I want to design it just in case we do. This ramp's function is simply to ensure that the AstroTurf approaches at an angle which ensures that the payloads will be able to make it over the top roller. Next up, it's time to start designing the support structure. Now thankfully, 80/20 is so ubiquitous that it's something you can go and pull models of different lengths directly from McMaster-Carr for. So here I'm laying out the 80/20 structure for the roller assembly. The main goal is to keep both rollers perfectly aligned while also giving myself the ability to adjust their spacing. That way I can dial in the amount of compression between them, which is actually what's going to drive the turf through the system. It also makes the whole thing a lot more flexible. I can swap parts, make adjustments, or iterate on the design without having to rebuild everything from scratch. I considered designing and employing a jack screw tensioner. However, I have worked with 80/20 enough to know that that probably wouldn't end up working in this case. Before I wrapped for the night, I got in an order in Amazon for my pillow blocks, my grip tape, and my Chicago-style screws, which I will use to try and join the pieces of AstroTurf. Not a bad night's work. It's day 5, Friday night, and it's time to start fabrication. During the day while I had been at work, I 3D printed the end cap, and somehow I managed to get the dimensions exactly right. Now if I could just learn to read so I could get the right size of PVC while at the hardware store.
Oh, you
Next up, I start trying to join the AstroTurf, which is absolutely filthy by the way, using the Chicago-style screws I ordered. This process absolutely sucks, and I make a decision that I have to find a better way. With the pillow blocks having arrived, I'm now able to assemble the main support system. This involves a lot of cutting and drilling of 80/20, in accordance with my CAD design. The next morning, I wake up bright and early and grab the correct size PVC from the hardware store. I figure since the sun's out and it's warm, I should hose off this AstroTurf because it is absolutely filthy. Then I set about to grinding down the extra material off of the inner shaft so that it would fit through the pillow blocks.
Alright, so I did a significant amount of grinding here. Got this thing on here. Now we have smooth rotation.
Then I start assembling the second roller. Followed by additional assembly of the support structure. These little end pieces remind me of Tron, the original, not the garbage new ones. After some brief cutting and some not too brief grinding down of the excess material on the shaft, I now have an initial assembly, and this is starting to look like what I envisioned in my CAD. While all this has been going on, I've been 3D printing the other end cap for the main roller. A few screw turns and some dead blow strikes later, I've got myself a main roller. Next up, it's time to design the secondary roller. This roller is mostly just for compression. It's passive and shouldn't be driven, and literally just creates a pressure point against which the main roller can compress the fabric. I didn't design this in CAD, mostly because I wanted to see how the main roller came out before I made any decisions about the second roller. As such, I'm doing a lot of my design on the fly right there on my work surface. The last thing I do for the night is start a 3D print for the end caps for this secondary roller. The next day, Sunday, day 7, I wake up and get right to assembling the secondary roller and its corresponding support structure. A busy morning full of 80/20 cutting, drilling, and assembly.
Probably one of the things I would do completely different if I was going to do this again. But like grinding these things down so that they'll fit through the pillow blocks is not super fun, and it's not very controllable. There's a better way to do it, and I don't know what it is. Not off the top of my head anyways. Anyways, it's just something to think about.
And so the grinding continues. And we grind, and we grind, and we grind. And then we take a break to play some Fallout 1 and get incinerated. Oh, Lord have mercy. Yikes-a-rooney.
Your bones are scraped clean, but
Following a solid morning of work, we have 90% of the support structure and the second roller in place. This is more and more starting to look like my vision. With the rollers assembled, I proceed to start applying grip tape to each contact surface on the rollers. This will help generate more friction, which in turn will help the rollers grip the AstroTurf better. With the rollers assembled and the grip tape applied, it's time to turn my attention back to this atrocious mess. Even after a pretty extensive pressure washing, this thing is still absolutely filthy. I have a couple of Chicago screws in place, enough to hold this thing into a loop. For now, I'm just going to use it to try and verify that my assembly works the way I think it does. I combine it with the assembled roller tube configuration, and here is the result.
All right, here we go. Hurts my hand. I should put the chain on. I should be driving with the motor, but it is moving, even though the other side isn't anchored. I think this is gonna work.
The next day, Monday, day 8, I commit myself to more securely fastening all of this AstroTurf together into a giant loop. In order to do this quickly and effectively, I decided to go with rivets. Now, I've never used rivets in my life, so this was a bit of a learning experience, and they turned out to be the perfect solution to this problem. The next day, day 9, and I still haven't figured out what I'm going to do about the driving motor. I have this freewheel sprocket left over from a previous project, so I go ahead and decide to just use that, fully knowing that the freewheeling capability of it might cause problems for me down the line. And this just goes to show that anything will fit if you hit it hard enough. This is also when I moved the entire crapparatus into the backyard, where I will be conducting my testing. After reassembling the entire thing, I then shifted to creating a mount for the motor to go on so that it could interface to the large sprocket on the main pulley. And every so often I stop and watch the dogs enjoy themselves. I love them so much, and I'm doing this all for them. And for Lauren. And for myself. But mostly for them. As the sun sets on the 9th day, I'm very close to having a functional system, mechanical-wise. My power supply and speed controller for this motor are a couple days from being delivered, and rifling through my box of spare power supplies, I don't see anything that comes even close to being able to generate 24 volts at 16.5 amps. I have my benchtop power supply, but that tops out at 10 amps. It's not a great idea, but I decided to give that a go. And in a way, I'm glad I do, because yes, it doesn't work, but it does help illuminate some problems that I didn't know I had. Okay, big takeaway after that abysmally failed test. Now, I kind of knew that power supply didn't have enough power to move that motor. As a result, the motor couldn't pull. You'll notice I put this tarp underneath the AstroTurf. AstroTurf on AstroTurf contact causes a lot of friction. It's almost like Velcro. So I wasn't even able to hand pull this thing. There has to be some kind of slick surface underneath the entirety of the run. Noted. Anyways, plenty to do for tomorrow. Made some decent progress tonight. After a good night's sleep and a day of work, I got back to it, only to discover even more complications that had reared their ugly heads once I moved the system into the backyard. Okay, I figured out why this isn't working.
The bottom roller is bottoming out. I can't fit my fingers underneath there.
It's because the ground is bowed. Bottom roller has been actively fighting against me the whole time. So it's not that this thing doesn't work, it's just I need to raise this side probably a couple inches. So I'm gonna get some spacer wood and drop it underneath there, and hopefully that'll do the trick.
And so the clock keeps ticking. Also this night, I kind of low-key decided that it might be important for the lower roller to actually be actively engaged by the drive system. To this effect, I designed and started 3D printing gears to go on the ends of the lower roller. We were getting close now, and lo, the day came when my power supply and speed controller arrived. I was so excited to plug them in and take this project to the next level. I wired up everything perfectly, using all the appropriate connectors, and the moment of truth had arrived.
Little doomsday clock. No fire, no fire, no fire, no fire, no fire, no fire. I feel like that light should have turned on.
I opened up the power supply and I could not find anything overtly wrong with it, and with so little time remaining on my project clock, I really didn't have the bandwidth to diagnose someone else's bad engineering. So as a stopgap to get 24 volts at the appropriate current level, I went and picked up 2 car batteries. An expensive solution, but this late in the game, the only one that I could think of that made any real sense. Using jumper cables, I wired the 12-volt batteries in series to create 24 volts. Now that I had the power supply taken care of, I could set up the speed controller and get this system one step closer to being functional.
Fire in the hole. Come on, man.
You know, I'm not one to read Amazon reviews, but maybe in this case I should have. Because if I had taken 5 seconds to read even a couple of reviews from this particular speed controller, I would have found such gems as this, and probably have picked a different speed controller for this application.
This is super not good.
I once again endeavored to try and quickly diagnose any obvious issues with the speed controller, but there was nothing I could easily find.
Wow. This has been an absolutely ridiculous endeavor. First, the power supply that I ordered off Amazon shows up, plug it in, no LED, so I go and pick up 2 car batteries because it's my only fucking option at this point. And then I hook up the speed controller and the speed controller doesn't work. It's just so everything's I basically just have this, the only thing I walked away from today that works is this guy, powered off of these works. Yeah, well, no. It's like bare minimum requirement. Okay, and I did print this. This is rad. And I do have this guy almost done. So, I mean, maybe there's some good takeaway. I'm gonna have to wake up early tomorrow and like install all the and it's just gonna suck. Still got 27 minutes left, and I don't want to sit and watch it. And I'm not going to. I think I'm just going to call it. Today's been just an absolute day where everything goes wrong.
All right, day 13. At this point, I am desperately out of time, and the system is still not working. Not to mention, I just got slapped in the face with some of the biggest setbacks of this project. If only the power supply hadn't worked, this would be a lot more salvageable, but the power supply and the speed controller not working makes this a very, very, very difficult spot to be in. So let's go ahead and pile onto that. I wake up Saturday morning and get to work, and the first issue of the day presents itself. The aluminum shafts that previously fit into the pillow blocks suddenly don't anymore. I don't know if it's manufacturing tolerances or thermal contraction or expansion. However, at this point it doesn't really matter. The end result is I spend a couple hours grinding down these aluminum shafts so they will fit in the system. Once that gets worked out, I'm finally able to integrate the bottom roller's gear to bring it into the drivetrain and hopefully help pull the Astro Turf through. More contact, more compression, more friction, basically just forcing the system to behave. This should help counter any slippage that might occur due to the rapid acceleration caused by not having a speed controller. The next problem, the drive sprocket. It's a freewheel sprocket, and I have seen these things basically buckle under excessive torque. So, in order to counter any possibility of this happening, I go ahead and weld it, which immediately causes another problem. The heat from the welding ends up damaging the plastic bushing that I put between the sprocket and the shaft. So on my first run, the sprocket completely flies off. Now there's only one option left. I have to weld the sprocket directly onto the shaft. It's permanent and ugly, but at this point I am so out of time that I just have to do whatever it takes to get this to work. So I set to welding the sprocket to the shaft, and I run out of welding wire. Because why would anything go right in this project?
We're gonna go to the hardware store and get more flux for this stupid thing.
Once I return, I finish the weld, I reassemble everything, line up the chain, engage the gears, and give it power.
I don't ask for much, but man, it'd be cool if this would work. Oh, yep, that's hot.
I forgot how much power was going through these wires. The small gauge gator clip jumper wires I was using are not suitable to carry 24 volts at 16.5 amps. Swap those out real quick and try again.
Okay, we've got a number of payloads on the cargo belt. The cameras are rolling. And that chain is probably aligned as good as it possibly could be. Got a backstop. Got a trough. Let's see what happens. 3, 2, 1, engage. All right, we did it. With 50 minutes left on the clock, we got this thing to transport a bunch of payloads into the trough. Now the only thing left to do is to clean up.
Good news, everyone! We did it! But just barely. We effectively took a static patch of AstroTurf and turned it into a dynamic, self-cleaning conveyor litter box for dogs. And we did it in 2 grueling weeks. Now, of course, this was just a proof of concept, and as you've seen, there were a lot of setbacks and compromises made along the way. For an effective system, we would want much larger pieces of AstroTurf, preferably something that covers the entire yard instead of just a section of it. That being said, even at this scale, which was about 160 square feet, this was easily a successful proof of concept. The compression roller approach ended up being an absolute home run, which I am way stoked on, especially once we tied the bottom roller into the drivetrain. In fact, it worked so well that during one of the tests, the roller grabbed the trough and effectively projectile launched it out the other side of the system, which was both shocking and hilarious. Now, if I haven't made it abundantly clear, for a final system, speed control would be a must. Running everything at full speed was a huge risk, but my back was against the wall and it was a chance I had to take. And remember, it's not a bug, it's a feature. To really take this to the next level, we would also want to include some form of automation, be that a simple timer or something more advanced like a camera system that monitors the area for activity. Also, some sort of sprayer system, in my opinion, would be a huge plus for this, as it would help keep the system clean on its own, beyond just discarding payloads, especially for handling stuff that doesn't just roll away. But you know what? At the end of the day, we set out to answer a simple question. Can you automate dog cleanup? And despite all the setbacks, the answer is a resounding yes. I'm really happy with how this project turned out, and if you made it this far, thanks for sticking with me. And with that, we'll bring this installment of Doomsday Protocol to a close. So to all my fellow viewers, dreamers, tinkerers, and makers, thanks again, good night, good luck, and as always, stay frosty.